Hello and welcome. It is time to keep talking about the blue elephant in the room, PostgreSQL. One of PostgreSQL major features is multi-version concurrency control, which we call MVCC. MVCC is the mechanism that PostgreSQL uses to allow concurrent transactions on the same data. MVCC changes the way we deal with logs, vacuuming, and bloating. This is the first video of a series called MVCC, logs, vacuuming, and bloating. In this first video, we will concentrate on how MVCC and vacuum work and interact with each other. In the demo, I will show you how these features work together. Yes, it will not only be theory. We need to roll up our sleeves and grab the elephant by the tusks. My last video, I briefly explained MVCC, but let's review it. Whenever a record is updated, PostgreSQL will create a new version of the record. Then, when a table is vacuumed, the old version of the records are deleted. Vacuuming is the name of the process that deletes all rolled versions. Let's go to our first demo of how MVCC and vacuuming work and interact with each other. Welcome to the demo. Now, let's start digging into the problem. First, we're gonna create a fresh table called customers. Here, let me copy the code. Yes, well, if there is an old table, customers, it's gonna be dropped. Then I'm gonna create one with ID, name, and age, and I'm gonna insert a record. There, it is created. Now, let us check the content of the table. Yes, it is ID 1, name John, age 20. And now, let's see how many live tuples and dead tuples do we have. Yes, that's to be expected. This is a brand new table with a brand new record, only one live tuple. We haven't done any update, so we don't have dead tuples. So, or dead tuples are all versions of the in the concept of MVCC. So now, what can we do? Let's say now that we're gonna start a transaction. Begin transaction, isolation level, repeatable. Don't worry about isolation levels. We don't have to understand that right now. We will talk about isolation levels in future videos. But let's do this and then do the select statement. Select ID, name, age from customers. So it's still 1, John 20. That's to be expected. Now, let's open another session. This is a session that I already had opened. And let's copy the code and let's update the record. So yes, it is updated. If we do the select statement here, we're gonna see 21. But here, what's gonna happen if I run the query? Still reading 20. It's reading the old version because this is an open transaction, and because it's in isolation level repeatable read, it's reading from the same version. Now, I'm gonna delete the old version. I wanna delete the old version. So what do I have to do? It's simple. I do vacuum. Did it delete the old version? Let's see. Let's do select live tuples and dead tuples. No, you see we have one dead tuple. It hasn't been deleted because this transaction is open. So we have two records, one live tuple, one dead tuple. The old version, which is the dead tuple, the old version has the age at 20. The new version has the name at 21. But because the old version, it is still on open, in an open transaction, Postgres will not delete that old version until this transaction is committed. Now, let's say that now this guy, he's now 22. Now we have three versions, right? We have the old version that is grabbed, that is on the open transaction, that is 20. 21 is another old version that is free, and the new version on the live tuple that is 22. If we run this query, we're going to see that we have two dead tuples. Now, what's going to happen when I do vacuum? Because Postgres is only holding this, the 20. It's not holding 21. Is it going to delete the one that is not held by any transaction? Let's see. And the answer is no. What is the lesson here? So MVCC creates a version of each record. And when a read statement grabs a version in repeatable read, it will not let the version be deleted, any version. Now, let's say that we have a table that is 1,000,000 records, and we have query that grabs 100,000 of those records, performs a join with 100 tables more, and performs some aggregation and all complex calculations, and that query takes an hour. So when it starts, grabs those versions, but in less than half an hour, the application updates those 100,000 records 10 times. What's going to happen? We're going to have 10 dead tuples per record. For 100,000 records, it's going to be 1,000,000 dead tuples. And Postgres is not going to vacuum or delete those old versions until the transaction is completed, committed. As a result, there might be an unintended consequence of performance degradation, because now Postgres has to delete 1,000,000 records at the same time, and increases the I/O and decreases the performance. Of course, to finish this demo, let's do commit. And now let's do vacuum. And let's check. Yes, it deleted the dead tuple. But I hope that you understood how MVCC and vacuum interact. That when there's an open transaction grabbing an old version of the road, none of the dead tuples in that row, on any of the rows that are busy and grabbed by a transaction, they're going to be vacuumed until it is done. And I find that this is one of the major causes of bad performance, because we have long running queries on tables that are heavily updated, and we have also at the end, when those queries are done, we have sometimes millions of records that need to be deleted, and that causes PostgreSQL to have performance at the bad performance at the disk level. Well, I hope you enjoyed this video. Don't forget to subscribe, and feel free to give me any feedback. If I need to explain this any further, I will, but I will keep talking about MVCC. I will keep talking about isolation levels, locks, and let's keep talking about the blue elephant in the room.